Okay, so this question here is saying, let f of x equal x squared. Sketch the graphs of the following functions about -2 to +2. All that this part right here means is the domain on the graph is going to go from -2 to 2. So let's set up our graph real quick. Let me get a darker color. Okay, so let's call this 1, 2, -1, -2, 1, 2, -1, -2. Okay, so that's what that means. We're only going to worry about graphing the function in between these points right here. So let's find out what we're graphing. Okay, f of x plus 1. Well, this is our function x squared. So look at this as like you're going to plug this into just the x. So this is going to end up being x plus 1 squared. And if we expand this, I don't know if you know this, but anytime you have a binomial squared, like a plus b squared, that equals a squared plus 2ab plus b squared. So in this case, x plus 1 is going to equal x squared plus 2x plus just 1. Okay, so we have to graph this function here. You can just plug that into your calculator or solve for the x-intercept, and you know it's going to be shaped like a parabola because you've got your highest order term is to the second power. It looks like it's going to intersect at -1, because if we take -1 squared plus 2 times -1 plus 1, that's just 1 plus -2 plus 1, which gives you 0. This 0 here indicates that that's where your x-intercept is. Okay, so that is going to look like this. It's going to be a parabola that touches the x-axis here, and you know parabolas look like something like that. It's not the best, but that'll do. Okay, let's do the next one. Change colors. Okay, f of x plus 1. He's probably trying to not confuse you, but make sure you know the difference between f of x plus 1 with all that in the argument and just your function, and then add 1 to it. So that's just x squared plus 1. That's easy to graph. Again, you can plug it into your calculator, or if you just get comfortable with graphing, you know that this plus 1 is telling you where it intersects the y-axis. So that's just a regular old parabola centered at the origin and moved up 1. That's going to look like this. Let me scoot this up. Okay. Moved up 1 right here, and then again just your regular parabola. It's kind of sloppy. I'll fix it. whatever, that's fine. Okay, f of 5x. So again, just anything that's ever in this argument here, plug that into the x. So it's going to look like, well, let me change colors so you can follow the graph. I'll do that in pink. Nah, pink's going to be too close. How about green? So that's going to be 5x quantity squared, which is going to give you 25x squared. When you're graphing this, again, just look at this x squared. It's going to be a regular parabola centered at the origin, but this 25 is actually going to compress your parabola, so it's going to be a really skinny parabola. If you had like a number, like say your number was a, and it's greater than 0 but less than 1, so you know, like 1/2. If it was 1/2 x squared, that would actually expand it and make it drawn out like this. And the closer it gets to 0, the wider it gets, and the larger. Obviously at 1, you know, you just have your normal parabola, but as the number gets greater than 1, it starts to look more like this here, like a really skinny, compressed parabola. So 25x squared is going to look something like this. It'll be centered here, but really skinny, like this. And this last one is, I'll do that in yellow, 5 of f of x, that's just 5x squared. Same thing, just going off of what I just explained here. It's going to be a same parabola centered at the origin, but it's not going to be as compressed as the 25x. It would be, you know, just like this, you know, still centered here, but just a little wider, like this. Okay, so I think that should answer that question. If you have any more questions, let me know.